today we get into the cubic roots. Okay, so with square roots, the most commonly used problems that we use for square roots were area, right? Well, cubic roots, the most commonly used thing that we use them for, is measuring volume. Volume is three-dimensional, right? Where area is two-dimensional. So when we find the edge lengths of the cubes with volumes of 127, 64, and 125 cubic units, notice how it's not square units anymore. So in terms of if the volume is 1, our unit of measurement is now, it's a little 3 now because it's cubic. And in 3, think of three-dimensional. All right? So what would the edges be if the volume is 1? And basically it's going to be some number times itself 3 times now, not twice. That's the difference between squares and cubes. So what do you think, what number times itself 3 times will give you 1? 1, right, because 1 times 1 times 1. So your edges are here, length, width, and then height. Okay? And the formula for volume is length times width times height, with height being the new, we saw length times width with area, right? We had the height because now you make a two-dimensional object three-dimensional. Okay? So what do you think the edge lengths would be if the volume was 27? You got to think of a number that can multiply to itself 3 times. Angelique? 3. Good. Because 3 times 3 is 9. Multiply that by another 3, that's 27. So again, length, width, and height would be 3s. What about 64? Angelique? 4. 4 times 4 is 16. 16 times 4 is 64. So your edge length here is 4. And then last but not least, 125. Angelique is the only one who wants to participate today. Everyone's just going to kind of sit here like bumps on a log. Haley? 5. Because again, 5 times 5 is 25. Multiply it by another 5, and that's 125. So if you notice when we did the squares, we had to kind of get big increases. We had to kind of increase the length and the width pretty big, right? Notice how these are kind of subtle changes, but look how the boxes increase. Because you're not only increasing length and width, but you're increasing height. So the stuff that you can fill inside the box really, really increases. Now again, using squares to find your volume, well, now the opposite. Now, this is what we call a cubic root instead of a square root. Okay? So like yesterday with square roots, we tried to figure out, okay, well, if it's a square root of 81, what number times itself is the root of 81? And we find out that it was 9. Well, now you got to figure out what number times itself 3 times is the root of the cubic root of 1. Well, this one obviously is 1, right? What about this one here, the cubic root of 27? 3, right? Because if 3 times 3 times 3 is 27, the cubic root of 27 is 3, because 3 times itself 3 times gives you that. So obviously this is 4 and 5. Okay? So cubic roots will have that little root in there. Now again, I'm going to try to make this calculator free, but with the cubic roots it's a little tough. If you want to find the cubic root, if you hit the math button, it's number 4. It's got the little 3 in front of the square root button. So then just put the number you want to look up the cubic root for, and you hit close the parenthesis. So it's number 4 on the calculator once you hit the math button. Okay? All right, so we're going to give you guys a shot at this. Again, try doing this without a calculator. So what is the volume of a cube if its edge length is 5 units and if its edge length is 2.5 units? Kind of similar to the problem we did yesterday, right? But it's not square root anymore. It's cubic root. And then see if you can find for me the numbers under in the box. The first one hopefully should be a little easy. The other one, you might have to just do a little bit of calculating on your paper. So I want you to just give you a few minutes to work as a team and see if you can figure this out. Just B1 and B2. Okay, we're gonna pause. What you come up with? So if the volume of a cube, or if the edge length of a cube is 5 units all the way around, what's the volume, Claudia? 125 what? Units what? Cubic units. Now yesterday we did this almost same one with squares, right? 2.5 squared was like 6.25, right? What is 2.5 cubed? Anyone figure it out, Angelique? Yep, 15.625 cubic units. Good. So obviously what goes in here in the box? The cubic root of some number is 5. Yep, that's your 125. And then the cubic unit of some number is 2.5. 15.625. So you see how we can go forwards and kind of backwards a little bit. All right. So yesterday, remember we talked about, I showed you how the square root, if you took the square root of a number squared, it's, well, same thing with the cubic root. If I take the cubic root, because x cubed means this, right? So if I got x cubed and want to find x, I can take the cubic root of x to the third. Because again, x to the third, if I take the cubic root of that, is x times x times x, right? So the root of that is x. Just like the root of 125 is 5, because 5 times 5 times 5 is 125. So you see how that kind of works with the squares the same way? Except now it's just one more number. So if I cubic root both sides to solve for x, the cubic root of 27 is, we've already done this one, 3. Because 3 times 3 times 3, right? Now, here is what makes cubic roots special. Remember, there is no way you can come up with a negative answer for a square root, right? Because like you can't have a negative and a positive, right? But you can have an actual negative number with a cubic root. Because think about this for a minute. What's a negative times a negative times a negative? It's a negative. Two negatives are a positive, right? And then you take that positive number and multiply it by a negative for a third time, and it becomes negative. So when I cubic root both sides, right, the cubic root of negative 27, well, if the cubic root of 27 is 3, what do you think the cubic root of negative 27 is? Negative 3. So we can have negative roots in a cubic root because of that multiplying integers rule. Negative times a negative times a negative. That third time, it'll make it negative, right? Square roots is a little different, right? Negative times a negative is a positive, and a positive times a positive is a positive, right? Square roots are or cubic roots are different. So this one's a little tough. All right, so think about this now. If I cubic root 1/8, I'm gonna write it off to the side here. Sometimes it's easier just to take the cubic root of the numerator and the cubic root of the denominator. So obviously, what's the cubic root of 1? What times what gives you 1? 1. Now what about the cubic root of 8? What times itself 3 times gives you 8? 2. 2 times 2 times 2. So the cubic root of 1/8 is a half. And think about it. If you take these 3 fractions, right? Let me erase this over here. Just to show you. We can check it by going, okay, well, what's a half times a half times a half? Well, when we multiply fractions, we just go straight across, right? So 1 times 1 times 1 is 1. And then 2 times 2 times 2 is 8. And that's how you can go understand about the root with fractions. Okay? Now for D, the cubic root of some number is 27, right? So Over here, we took the cubic root to find x. Well, now we got to cube all these, right? To find x, which means we have to cube the 27, which means we got to figure out what 27 times 27 times 27 is. And that's a really big number. So who's got a calculator? Here's a little trick. Let's show you something. Hit 27. Hit that little arrow above the divide sign. And then put a 3 in. Because it'll say 27 with the arrow to the third power. You're doing an exponent. What number did you come up with? Yeah, 19,683. So 27 is the cubic root of this number. Big number, isn't it? So if the cubic root of that number is 27, what number do you think is the cubic is negative 27 the cubic root of? Tim. Yeah, it's just the opposite, right? And then for f, again, we're going to cube both sides. Well, when I cube negative 1/8, that's like saying this. And here's that little issue with a negative times it. Is this going to be a negative or a positive number? Negative, right? Because a negative times a negative times a negative is a negative. Right? Two of them are positive, and then the positive times the negative is a negative. So we know what 1 times 1 times 1 is. What about 8 times 8 times 8? 8 times 8 is 64, right? Now you just got to do it one more time. Was it 512? So you'd have negative 1 and 1 over 512. That's a pretty small fraction, isn't it? Yeah, really small. So just like yesterday, again, if we're trying to figure out the number that we cubed to get the 27, that's kind of like your side length again, right? Your length. So A, B, and C are your side lengths of the cube. And D, E, and F kind of deal with your volume, right? The bigger number under the root. All right, so yesterday, you have to try to do this without a calculator. Yesterday, we did the square root of 10 and tried to figure out where it's between, right? And we figured out it was between 3 and 4. And we did almost the same stuff, right? Which number was it closer to? And then we tried to estimate it, right? Well, now we're going to do the cubic root of 10. So do you think that root should be smaller or bigger than what we figured out yesterday? Smaller, right? Because yeah, if you're trying to if you take the square root of 10 and the cubic root of 10, which is inside the root obviously the same number, but now you're talking about multiplying something twice as opposed to 3 times. Didn't that number you multiply 3 times need to be smaller than the number you'd multiply twice if you're going to try to get the same number? Yeah. So I want you, remember, whole numbers are 0, 1, 2, 3, all the way up, right? No decimals. So I want you to see where you think that lies between. You know it's got to be smaller than from 3 to 4, right? We just kind of established that, so we kind of got you going a little bit. And then again, without using a calculator, see if you can tell me the value to 1 decimal place, the tenths. So same thing yesterday, but now it's cubic root. And try to avoid the itch of typing in those buttons in the calculator. All right, let's see how you do. So think of perfect cubes. That means the root is a whole number. I already told you the cubic root of 1 is what? 1. So what's the next one up? What cube has a root of 2? What perfect cube has a root of 2? 8. So the cubic root of 8 is 2. All right? What's the next one up? And we did that work up top already. 3 is the root, right? What's the cube? Cubic root of 27, right, is 3. So where does cubic root of 10 lie between there? Yeah, between 2 and 3. We don't need to go any higher, right? So think of the numbers. This gets kind of crazy. So if we had the cubic root of 8, which we know is 2, right? And way over here, put it over here, is the cubic root of 27, which is 3. Well, think of all these numbers in between. The cubic root of 9, the cubic root of 10, which is the one we're looking at, cubic root of 11, the cubic root of 12, cubic root of 13, all the way 14, 15, 16, all the way to 27. What number is that closer to? 2 or 3? Yeah, absolutely. It's closer to 2. It's not even in the realm of 27, right? So now, thinking about that, right? So the value of this is 2 or 2.0 if you're rounding the nearest tens, right? The value way down here is 3 or 3.0. So if you were to round this to the nearest tenth, what'd you guess? How many people said 2.1? Okay, few groups. What about 2.2? Did anyone go higher than 2.2? Because you got to figure halfway is about, I don't know, 19, somewhere around a cubic root of 17, 18-ish. Is like 2.5. No one went higher than 2.2? Well, your exact number is actually this. 2.154, da-da-da-da-da-da-da. So either of these numbers would have been a great estimate. And again, your thinking is, it's so close to this number and so far away. I mean, it's not even close to the halfway point, which is like somewhere over here. So again, you want to think of a lesser tense number because it's closer to that 0.0 than anything, right? All right, let's turn the page. Now, we've briefly kind of talked about this. So which number do you think is bigger? The square root of 8 or the cubic root of 8? What value do you think is bigger for that? Tim? Yeah, the square root is bigger. Now, why? If you find the cubic root of 8, that's 2. If you do the square root of 8, it's like 2.8 something, 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 something. So why would a square root always be bigger than a cubic root? Jack? Right. If you're trying to multiply something to find the same number, right? Like, because we know 2 times 2 times 2 is 8. And if I'm trying to do the same thing but multiply less times, it has to be bigger just to get there, right? So the more times you multiply, the smaller the numbers have to be if you're going after the same number, right? If you can take it up to the 4th root, that would get even smaller, right? Because now you're talking about multiplying something four times. So the more times you multiply and you're trying to get the same answer, obviously the more groups you break it into, the numbers have to be smaller if you're going to get the same answer, right? So a square root will always be bigger than the root of a cubic root. Because again, it's more times you have to multiply. Does that make sense? Sorta? Does that make sense? Now again, if they're different numbers, then that's a different story. But we're going after the same number. Okay? The biggest difference is in the roots. Because again, we're only multiplying twice here to get this answer. We're multiplying 3 times to get this answer. So it has to be smaller. All right. We should be really good at this chart now. Right? You kind of figure out the pattern from yesterday, right? So the cubic root of 3 is, and then, right, because they're all underneath the roots here, right? All your answers. 216, 343.
At this time, the hallways are closed. Students and staff, students should stay in the classroom for the hallways to be closed. Thank you.
Now I'm not going to go too crazy and tell you you should know all 15 roots, but you should at least be pretty comfortable up to 10. Because you know 10's got to be 1,000, right? 10 times 10 times 10. Anything below that, you should kind of have a good at least memory of that. Cubic root of 15, that's a little much. Okay. But again, all this means is that number times itself 3 times. It's one more than the square root. So we go back to the roots now. These are just 15, 14, 13, and so on. All the way back to the top. So I really, if you can get to here and know a lot of the cubes and the cubic roots of those, you'd be pretty good. Because remember, we're going to take this quiz Tuesday next week. So it's calculator free. So you do got to know those, okay? So if you go up to 10, you're good. If you know them up to 10. All right. So the assignment for this, because I goofed up yesterday. All right. So I know that was the assignment I put up yesterday. So if you did that assignment yesterday, you're